Hello everyone, I am Dr. Godanda Raman. In this section we are going to discuss with last few years semester question paper. First of all, to discuss with July 2025 part A 20 MCQ. Each questions are 1 mark, so total 20 mark. Each unit 4 questions to cover, so 5 units, so each 4 questions, so total 20 mark. Now first 4 questions. So first question is eliminating arbitrary constant, and then second questions first order partial differential equation, and third one is second order or higher order. So right hand side e power ax plus by particular integral type, and when the right hand side 0, then it's nothing but to find the only complementary function. This is also second and higher order. And then fifth to 8th questions are Fourier series second unit. Now the tan x is a periodic function with the period related questions, and then 0 to 2 pi related problem, and find the root mean square. And then the 8th question is half range cosine series, the range 0 to pi. And then 9th to 12th questions are unit 3 application of partial differential equation. Now this is a standard questions because when the given equation, and then so other is heat equation is mentioned, then one dimensional wave equation, and then other one is the heat equation. Then 13th question to 16th questions are Fourier transform unit 4. So first one is Fourier cosine transform to calculate, and then these are the properties. 14th, 15th, 16th are property related problems, and 17th to 20 unit 5. So Z transform. So this is a Z transform of some f of n values or calculation, and then 19th to 20 is nothing but Z inverse of to calculate some problem. And then part B 8 more questions, each unit either or choice, so 8 more, so total 5 questions 40 more. So the 21A, the question is nothing but Lagrangian method, it's a multiplier method. And then or choice second question is this is a second and higher order, right hand side value e power ax plus by and x power m y power n. So type 1, type 3 related problem. And 22A unit 2 Fourier series. So Fourier sine series or Fourier sines, both Fourier sine series, the range 0 to pi, 0 to L. So L is nothing but 1. And 23AB is nothing but, so this is a problem one dimensional, when the string is problem related is a one dimensional wave equation, the temperature one dimensional heat equation. And 24A, so Fourier sine transform, Fourier cosine transform, and then this is a self reciprocal problem, Fourier transform. And 25A, 25B either or choice, this is a finding the inverse Z transform of using long division method, and this is also find the Z inverse transform of using partial fraction method. So this is a 5 units. And part C 1 questions 15 mark, so 2 given to write any one. So the 26th question is nothing but 5th unit, so Z transform related problem. And then 27th is the second unit Fourier series, in the Fourier series harmonic analysis problem. So this is a July 2025. And next May 2025 part A. So yeah, as usual same pattern, 20 questions each 1 mark, 20 mark, so each unit 4 questions. So first question particular integral, so right hand side x power m y power n form, and then second question right hand side 0, so only complementary function is our general solution. And then third question is, so this is the equation is given, find the solution. And then next it's a Lagrange's linear equation to solve. And then 5th to 8th, 5th one is periodic function, the question is find the period, and then another condition is given to find is a even function or odd function, whatever. And then function of x given 0 to 2 pi, then a naught is a question, and then root mean square. Then 9th question to 12th question unit 3 application of partial differential equation. So this is a solution one dimensional wave equation. The 10th one is one dimensional heat equation, and this is also 11th and 12th, so general form. Then 13th to 16 Unit 4 Fourier transform. So this is the 13th is the properties of Fourier transform, and this is sine transform to calculate sine transform of 1 by x value, and this is also x power n f of x Fourier sine transform. So up to 16th questions are unit 4, and 17th to 20th unit 5 z transform. Z of some function is given to find the value, then this 2, and z transform of 1 by n factorial, and this is a property z of f of n star is a convolution theorem z transform. Then part B. So part B 21A or 21B. So the first one is a Lagrange's linear equation multiplier method. So now our choices, right hand side e power ax plus by and x power m y power n. So type 1, type 3. And then 22a, 22b. So 22a is nothing but range 0 to 2 pi, the function of x is given, and then minus pi to pi, the function of x given to find the value. And 23a is nothing but string type of problem, one dimensional wave equation and one dimensional heat equation for our choice, rod, so temperature. So 23a one dimensional wave equation problem, 23b one dimensional heat equation type of problem, and 24a Fourier transform. For here find the Fourier cosine transform, Fourier sine transform, or here the function of x given, now some power 4, when the power 4 to find the value Fourier transform. And 25a inverse z transform using partial fraction method, or 25b find the inverse z transform using convolution theorem. And part C, 2 questions 26, 27. So answer any one questions. So 26 z transform, 27th also unit 2 Fourier series, and 26th unit 5 z transform. Now the 27 harmonic analysis problem. And next question paper November 2024. Then part A 20 questions, each 1 mark, total 20 mark, each unit 4 questions. So first unit is partial differential equation, eliminating arbitrary constant, eliminating arbitrary function, and then arbitrary constant if number of constant, number of independent variable, and then complete integral. So these 4 questions are unit 1 partial differential equation. And then 5 to 8 unit 2 Fourier series. So the range 0 to L, the f of x to calculate, 0 to 2L, 0 to 2 pi, minus pi to pi, to find the function of x given, to find the value of bn, and then a naught, and this value I think f of x general Fourier series, and then this is the means root square. And 9th question to 12th questions, unit 3 application of partial differential equation. Now the equations are given, so now to find the one dimensional wave equation or heat equation. So this is a PDE equation is given to find the constant value. And then 10th question is initial boundary condition, then equation is given, and then one dimensional wave equation based on that to calculate the point, and this another classify the PDE. And 13th to 16th unit 4 Fourier transform. So this Fourier transform 13th question is property, and then 14th question is also based on the property, and cosine transform to calculate, and then here convolution theorem. So some property based on this 4 questions are at most related to solving property related. So 17 to 20 is a transform of f of n, and this is a convolution theorem, is a transform of convolution theorem, and is it inverse transform, and then poles to calculate. So these are Z transform. And part B 21A Lagrangian method. So Lagrangian method is nothing but multiplier, and then next question is e power ax plus by and sine ax plus by, it's nothing but homogeneous higher order partial differential equation problem. And then 22a is nothing but minus pi to pi Fourier series, unit 2 Fourier series, minus pi to pi f of x x square, and this is a we can find the convergence values. Our choice is a half range sine series, the function of x given, the range 0 to pi. So hence deduce that after finding the series to reduce. And 23a, it's a string, so this is a one dimensional wave equation. And then our choice 23b see here temperature is mentioned, therefore it's a one dimensional heat equation. And 24a Fourier transform. So now the question is find the Fourier transform and evaluate some integration of, I think Fourier transform, inverse Fourier transform possible, and this is a unique using transform technique, so some Fourier transform problem. And 25a is the transform of some function, and our choice is that inverse transform of using convolution theorem. And part C 15 mark, two questions are given, write any one. So 26th unit 2 Fourier series harmonic analysis problem, and 27th first one is Z transform, other one is inverse Z transform. And then next question paper July 2024. So first four questions are unit 1 partial differential equation. The first one is find the complete integral standard type problem. This is the second order or higher order, and type 3, and particular integral type 1, and complete integral is a standard type first order, it's a Clairaut's form. And fifth question, find the periodic function period and even function to calculate, then root mean square, and then half range cosine series. So these four questions are unit 2 Fourier series. Then 9 to 12th questions, application of partial differential equation. So wave equation is given to find the parameter values, and one dimensional heat equation related problem, and then string, it's nothing but one dimensional wave equation, and the initial boundary condition to calculate. And 13 to 16 questions are unit 4 Fourier transform. This is a Fourier transforms when the function is given general formula, and this is a properties, this is a convolution theorem, and 16th is a Fourier cosine transform to calculate. Then 17 to 20 Z transform unit 5. So now Z function of some value, Z function, Z inverse of some function to calculate. And part B 21a is a Lagrange's method problem, or and then it's a sin y, so maybe type 2 sin of ax plus by, second order or higher order homogeneous partial differential equation, homogeneous linear partial differential equation. 22a, the range 0 to 2 pi, find the Fourier series function is given, or half range cosine series range is 0 to L when function of x given. And 23a is nothing but Fourier application of partial differential equation, one dimensional wave equation, or one dimensional I think this is a temperature related problem, one dimensional heat equation. Unit 4 Fourier transform. Now this is a Fourier transform type of problem using Fourier transform technique, and our choice is partial identity related problem, Fourier transform, unit 4. And unit 5 Z transform. So when the function of x n given, find the Z transform. Our choice is Z inverse transform using long division method. And part C, given, write any one. So one question is a harmonic analysis, another question is a temperature one dimensional heat equation type of problem, but the non-zero temperature. And then next question paper May 2024, and 20 questions, each 1 mark, 20 mark. So first 4 is a first unit partial differential equation. So this is a eliminating arbitrary constant, particular integral type 1, and then complementary function to calculate, and then this is a complete integral to write. So this 4 questions unit 1. Next 4 question 5 to 8 unit 2 Fourier series. So the range minus pi to pi, find an, minus pi to pi, find a naught, and then f of x given minus pi to pi. The final Fourier series values are given. Now to find this range, and then root mean square value f of x given, the range 0 to L. Then unit 3 application of partial differential equation, 9th question to 12th question. This is a one dimensional heat equation. This is a application. So now is a classification of PDE. And 13th questions to 16th question unit 4 Fourier transform. Now this is the form of convolution theorem of Fourier transform, And then 14th question is nothing but Fourier transform when the function given properties. This is also property related questions. And 17th to 20 Z transform unit 5 Z inverse of some function given to calculate, and this is also Z transform and then Z transform. Now this is a differential equation of Z transform. And part B, 21th A question. So type 1, type 3, e power ax plus by, x power m, y power n, second and higher order partial differential equation. And then our choices, find the general solution is a Lagrange's linear equation method, multiple integration, multiplier Lagrange's method. And then 22A, so Fourier series when the range minus 2 to 2, it's nothing but minus L to L range, and then harmonic analysis problem. 23A, one dimensional wave equation, because string is nothing but one dimensional wave equation, and here something equation is given, the equation is nothing but, so see 4 conditions are given. So when is given 4 condition, and the equations also one dimensional wave equation. And then so this is a Fourier transform. So find the Fourier transform when the given problem, or Fourier cosine transform. Then Z inverse transform using long division method, Z inverse transform using residue theorem method. Then part C, this is a heat equation, and other one is differential equation of Z transform. And then next question paper, November 2023. So first 4 questions are unit 1 partial differential equation. Now find the standard type, and then first 2 questions standard type, this next one eliminating arbitrary constant, and then complete integral, right, related problem, and then this is a particular integral type 1. And 5 to 8 Fourier series, 0 to 2 pi, find a0, minus pi to pi, and then find the formula of Fourier even function related problem, root mean square value, and then half range sine series. Then 9th to 12th is application of partial differential equation. Now the equation string one dimensional wave equation solution to write, and one dimensional heat equation, so show the equation, and boundary condition, what are the how many boundary condition, and then classification of partial differential equation. 13 to 16 questions are Fourier transform unit 4 and self reciprocal related question, Fourier cosine transform, and then this is the property related questions, this is also property. 17 to 20 Z transform, Z inverse transform, and when find the poles, and then differential equation. Part B, 8th mark question, so either or choice, 5 questions each unit, 2 questions either or choice. So 21A, Lagrange's linear method, multiplier method, and 21B is a second type higher order, homogeneous higher order. And so 22A, unit 2 Fourier series, the range minus pi to pi, or choice harmonic analysis problem. And 23A, it's a string, so one dimensional wave equation problem. Then another one is so one dimensional heat equation. And then 24A, Fourier transform, the range is given, only find the general Fourier transform, and the R choice is find the Fourier transform using the property. Then 25A is Z inverse transform using residue theorem, or Z transform general function is given. Part C, 15 mark, 2 given, write any one. The first one is Z transform, and then second one is one dimensional wave equation problem. And next question paper, May 2023. So first 4 questions are unit 1 partial differential equation. The first one is standard type, and then this is a third type particular integral, and this is also particular integral, first type of question, and this standard type question. And next Fourier series unit 2, find the period, and then even function, and then root mean square, and then using some condition. So 9 to 12th questions are application of partial differential equation. So 9th one is one dimensional heat equation related question, and then general equation is given, find the initial and boundary condition, number of initial boundary condition, and write the one dimensional wave equation form, and then heat equation, what are the temperature. So this is the up to 12th unit second. Then Fourier transform, this is application of unit 3, and next to Fourier transform unit 4. So properties, general Fourier transform formula, then sine transform formula, and then what is the condition, properties related, then this is a convolution theorem. Then 17th to 20th Z transform, Z inverse transform, and then convolution of Z transform, Z inverse transform of function is given, find the poles. And then part B, so 21th A question, Lagrange's linear method, or this is a second type, homogeneous higher order partial differential equation. Then unit 2, 22A, Fourier series 0 to 2 pi, or half range cosine series 0 to L, and then function is given. 23A, this is when the string one dimensional wave equation, or this is a temperature one dimensional heat equation. 24A, find the Fourier transform, and then this is a general Fourier transform, but the technique to apply using some property. And Z transform unit 5, Z inverse transform long division method, then this is a general Z transform problem. Then unit 5, this is a part C, 15 mark, 2 given, write 1. So 26 is the harmonic analysis problem, and then next is temperature, so non-zero temperature is a one dimensional heat equation, so application of partial equation unit 3, so unit 2, unit 3. So these are the last few years semester question paper. Then the MCQ answer I will be uploaded in the next video. All units, separate unit MCQ with answer I will be uploaded. Thank you.